Good afternoon, everybody. So today we shall continue our discussion on convolution code. Uh, so in the convolution code, basically we have two convolution or a number of convolution uh, operators are used to encode the message. And then instead the difference between the other kind of the last few, that is the cyclic code and the linear parity code based schemes, is that here we are not sending the message bits. So in both of them we have seen that we have sent the message bits, but here what we will do is that the code is generated by convolution operation of the message bit and a convolution operator, which also here is known as the generator. So the basically this one, there can be number of generators depending on the uh, structure. So here for this there are two generators like GI1 and GI2, and GI1 and GI2 will have convolution responses depending on the number of shift register. In this case, there are two shift register, so therefore length of the impulse response of GI1 and GI2 would be say 3. Length would be 3 because there are two shift register, and if we say input is suppose, what is the output we have put? Input is sorry. Output we have defined as xi. Okay, so usually these outputs are also referred as the parity bits. So input is the message input. Now if the message input here it is say M0, or Mn we can say, then after one shift it will be say Mn minus 1, and then this would be Mn minus 2. Now the output of the convolution operation, so there will be one output from this and another output from this convolution operation. So convolution is nothing but shift, multiply and add. So here of course multiply is not need not be implemented because we are in binary domain. It will be either 1 or 0. So therefore here this will be simply addition will takes place, and then we will have the output out 1 and out 2. Now this is a multiplexer. So which basically make it serial. Serial output at this place. This also can known as the parity bits. In literatures, they are also referred as parity bits. So parity bit 1 and parity bit 2 is generated, and then correspondingly they will be multiplexed and to make it serial. So therefore, here the main theme is that instead of message plus parity or parity plus message, only parity bits are transmitted. So code rate in this case is approximated equal to 1 by number of generator or number of convoluters. So here in this particular case, therefore rate equal to half. Here rate equal to half. However, and the length of the convolution is of course 3. So length of the convolution is given by the number of shift registers plus 1. So length of convolution is given by number of shifts shift registers plus 1. So in this case, that is in this case it is 3. So we can put some convolution, like here we have not defined. We can define GI1 and GI2. So GI1, suppose for example, suppose GI1 G1 G01 G0 G0 or G1 G0 G01 G0 G1 sorry G11 G21. This is the first convolution. impulse response is suppose defined by 111, and the second one is suppose 101. So the message is let us take one message. M0, M1, M2, M3, M4 is equal to 1, 0, 0, 1, 1. Now then what we will do, we will convolute and compute the outputs. So the outputs, let X be the output. Output be X0 and X1. So we will have, if we do the convolution, X01 would be G01 M0. No, sorry, this is equal to one. Similarly, X1 will have two overlap. So convolution is basically we are shifting the impulse response point by point through the message. So message is 10011. Our impulse response is 111. So 111 is symmetric. So basically convolution is first fold and then shift. In this case, both of them are symmetric. That means G1 is also 111 symmetric, G2 is symmetric. So folding or not folding generally does not matter. So therefore 111 will be passed through the message. So the first overlap was with 1, the second overlap with 1 plus 1 into 0 plus 1 into 1. So 1 1 will be here. That is equal to 1. So similarly we will have x1 2, so that is also equal to 1 because 1 1 1 is at this place. So that is equal to 1. Oh sorry, x2 here. X3 1 would be the 1 1 1 is at this place. 1, 1, 1. So that is also equal to 1. Then x4. x4 is 1 at this place. So 1 into 1 plus 1 into 1. So that will be equal to 0.
Sir, how is x2 1? I did not understand.
So x0 was at this place, the first overlap. Okay. So 1 was here and second one was here. The third one is here. Okay. So that is x2. So this is x2. This is giving x11. This is giving x01. So that means we are shifting this 111 through this message. Okay. So x31 is again we have here. So where was 2? 2 was here.
Okay, sir, so it will be the last digit or what? That or the
Yes,
okay.
yes. So now x4, because there are two ones, when they are added, this will be 0. Similarly, x5 also there are two ones here. So two ones are there. So x5 one has gone out, but two overlaps are there. Both are 1, so that will be 0. S6, it is just the tail of the impulse response will touch this, so that is equal to 1. So therefore, we have x1 is equal to 1, 1, 1, 1, 0, 0, 1. Then we have similarly we can compute x2. Similarly, in the same fashion, x2 can be computed with g2. g2 equal to 101 as x2 equal to 1, 0, 1, 1, 1, 1, 1. So now we have the two outputs. Two outputs are now multiplexed. So we will pick one from here, one from here. So then the multiplex output x would be, say, 1, 1, then 1, 0, then 1, 1, then 1, 1, 0, 1, 0, 1. There will be no gap. This will be going serially. Just for understanding, I have put these gaps. So the output, multiplexed output, will be a bit stream, one coming from the first convolution operation and one coming from the second convolution operation. We can also generate this one, this can also be generated by multiplication. Of the message polynomial and the generator polynomial. Because we know that those who have done that signal systems, that if we take the Z transform, this convolution becomes multiplication, and if we write them in terms of delay, so x1 would be therefore this is the delay representation polynomial of the 111 convolution operator. This multiplied by the message polynomial. Message was 100 10011. So 1 plus dq plus d4. So this will give 1 plus dq plus d4 plus d plus d4 plus d5 plus d square plus d5 plus d6. So this is nothing but 1 plus d square dq plus d6. So this gives 1, 1, 1, 1. d4, d5, nothing is there, 0, 0, d6 is 1. So this is this. So this way also, convolution could be done. So once the convolution is done and then multiplex, the parity bits are now transmitted. So this can be also, but for decoding purpose, usually decoding, because we are not having the message, so decoding needs certain effort. Decoding needs some kind of searching. Through the state transition diagram. So because other cases we had the message and parity, and we can always check whether it is in the error, and also we had that syndrome. But here it is not so. So here it is done through by tracking the state transition diagram. Now this state transition diagram is formed by taking the input, say input was say xk, the states are defined with x n minus 1 x or m, whatever, and x n minus 2. So that defines all the shifted ones. If there are more number of shifts, of course, that will give that many number of states. Here we have 2 digits defining the states, so therefore there will be 4 unique states. That they can take 0, 0, 0, 1, 1, 0, 1, 1. So once we define this, then we can put a state transition diagram. So the state transition diagram could be, we have the states 0, 0, then 0, 1, 1, 0, and 1, 1. So these are the 4 states. So between these states there would be various transitions. So because 0, 0 is the initial state and 1, 1 could be the final state for 2 stages shift registers. They can remain there. So that is the starting state can remain at start and final state can remain at final. The other states can change over to another state. Now, this here we can define that which is basically corresponding to the input, which input the output are corresponding to this transition, what input output combination. In the arcs the input-output combination. Is anyone rated? As input is xn, and then output could be out1, out2, or we have also defined parity, so it could be like P parity bit 1, parity bit 2, or we simply can write or P01 so therefore corresponding to each of these, when this is occurring, a state change is occurring, so we have to track this. So when, of course, 0 input is there, there is no state change for 0, 0. Similarly, if 1 input is there, so there is no state change of this one. So now the rest will change. So 0, 0, if it is there, 0, 0, 2, suppose we have 0, 1 to 1, 0. So if we have push an input 0, so this 1 will go out and 0 will be there. So then the parity will be, of course, the add will be 1 added with 0. So that will both will be 1. Similarly, here, if we push a 1, of course, then it will be 1, 0. Then the parity will be, because one is 0, another is 1. So if we add them, so both will produce 1. Similarly, here, if we push a 1 here, so then what will happen? This will becomes 1, 1. But then one output will be 0 and another output will be 1. Similarly, in this case, one input has to be pushed to 0 so that a 0 is inserted. So 0 is the input, and correspondingly we have 0 and 1, and that is 1, 0, 0 and 0 slash 0, 1. No. 1. So we shall see that with the help of this state transition diagram, how we can decode it. For that, actually, we have to trace the minimum path. And first, we have to kind of unfold the state transition diagram, what is known as a trellis diagram. So the decoding is performed by unfolding the state transition diagram into what is known as the trellis diagram. So next day we shall see study about this decoding. Today I shall stop here.
Sir?
Yes.
Sir, can you explain this state transition diagram again? Like, how are we getting this